Standing on the surface of Venus would be an incredibly hostile experience, unlike anything on Earth. Imagine a world where the temperature is a scorching 900 degrees Fahrenheit or 475 degrees Celsius, hot enough to melt lead. This extreme heat is due to Venus's thick atmosphere trapping heat like a massive greenhouse. The atmosphere is mostly carbon dioxide, with clouds of sulfuric acid making it toxic and corrosive. Furthermore, the pressure on Venus's surface is intense, like being 3,000 feet or 900 meters underwater on Earth. The sky would appear a yellowish color, and the landscape, though mountainous and volcanic, would be shrouded in thick, perpetual clouds blocking any view of space. Standing on Venus would be a hellish experience. Because of these harsh conditions, humanity will opt out of colonizing the Venusian surface. A viable alternative will be to build habitats in Venus's higher atmosphere where temperatures and atmospheric pressure is a lot more Earth-like. There will be two types of habitats, stationary and mobile. Humanity will also in later stages try to build fixed outposts on the surface of Venus, which primary purpose will be scientific research of the planet. Floating about 50 kilometers above Venus's hostile surface, these habitats are designed to be sustainable living spaces for humans, anchored in the more temperate and hospitable upper atmosphere of Venus. Here, the air pressure and temperature are somewhat akin to Earth's, making it one of the few places in the solar system where humans could potentially live long-term without the need for complex and heavy protective gear. These habitats, buoyed by large balloon-like structures filled with lighter-than-air gases, could offer a new home for humanity in the clouds of Venus. The colonies would be self-sufficient, equipped with life support systems to recycle air and water and utilize wind energy, which is plentiful on Venus. The habitats could house scientific laboratories, agricultural areas, living quarters, and communal spaces, creating a small, thriving community in the sky. From their vantage point, colonists could conduct extensive research on Venus's atmosphere, surface, and potential for terraforming. The concept of terraforming, or modifying Venus's environment to make it more Earth-like, would be a key focus. Scientists and engineers in these colonies could study ways to reduce the planet's extreme temperatures and alter its thick, carbon dioxide-rich atmosphere, paving the way for possible future habitation on the planet's surface. The idea of using these habitats as a stepping stone for terraforming Venus is both ambitious and challenging. It involves immense technological and scientific efforts, such as possibly introducing microorganisms that could convert the carbon dioxide in the atmosphere into oxygen, or deploying large mirrors in space to reduce the solar radiation reaching Venus. These concepts, while still in the realm of theory, could be researched and developed further in the Aerostat Habitats. The lessons learned from living in such an extreme and unique environment would not only advance our understanding of Venus but also enhance our capabilities for long-term space habitation and exploration. Mobile aerostat habitats in Venus's atmosphere are futuristic airships that serve multiple purposes. Imagine them as a blend of a floating laboratory and a permanent home for humans, soaring through the upper layers of Venus's atmosphere. Unlike their stationary counterparts, these mobile habitats can navigate through the dense clouds of Venus, making them ideal for exploring various parts of the planet's atmosphere. They are equipped with living quarters, research labs, and all the necessities for long-term human habitation, allowing scientists and residents to study Venus up close while living in the sky. The mobility of these habitats also enables them to connect various stationary aerostat colonies, fostering a network of human presence in the Venusian atmosphere. The design of these mobile habitats varies in size. The larger ones are akin to floating towns, housing more extensive facilities and a larger population. These bigger habitats focus heavily on scientific research, housing advanced equipment and laboratories for in-depth study of Venus's atmosphere and environment. On the other hand, the smaller mobile aerostats are more agile and primarily function as transportation vehicles. These smaller airships are crucial for interhabitat travel, ferrying people, supplies, and research materials between different floating colonies and research stations. Living in these aerostat habitats in Venus's atmosphere would be like residing in a high-tech, floating city in the clouds. Imagine waking up each day to views of swirling yellowish clouds outside your window with the sun shining dimly through Venus's thick atmosphere. Your home would gently drift in the sky, equipped with everything needed for comfort and safety: air and water recycling systems, areas for growing food, and spaces for both work and relaxation. Life in these habitats would involve a mix of scientific research and daily community activities, all while floating tens of kilometers above the planet's surface. In order for inhabitants of Venus to travel from their habitats to the surface of the planet, a sophisticated form of transport is needed. Because of Venus's harsh environment on its surface, no airships nor any other form of flying machine would be a viable option. The most suitable form of transport to Venus's surface would be a mechanical hoist. These elevators would serve a critical function, providing a direct, safe passage between habitable upper atmosphere and the unexplored surface of Venus. Imagine a sturdy, vertical structure stretching from the floating colonies down through the dense, corrosive clouds to the scorching, high-pressure environment of Venus's surface. The purpose of such an elevator is revolutionary. It would allow scientists and explorers to transport themselves and their equipment to and from Venus's surface without the need for complex and risky spacecraft landings. This would enable in-depth exploration and study of the planet's geology, atmosphere, and potential resources, significantly advancing our understanding of Venus. A spacesuit designed for Venus's surface would need to meet some extremely tough requirements. First, it must handle the extreme heat, as Venus's surface temperature is around 900 degrees Fahrenheit, similar to an oven's broil setting. The suit would need a robust cooling system to keep the astronauts safe and comfortable. Next, it must withstand immense pressure, about 92 times the pressure on Earth's surface, akin to being deep underwater. This means the suit must be incredibly strong yet flexible. Additionally, Venus has a thick atmosphere full of carbon dioxide and clouds of sulfuric acid, so the suit must have excellent air filtration and a completely sealed design to prevent toxic gases from getting in. Lastly, given the challenging conditions, the suit would also need to be highly durable and resistant to corrosion, ensuring the astronauts' safety in this extreme environment. Because all of these requirements, these suits would likely be incredibly bulky, unlike any other. An outpost on Venus's surface will serve several important purposes. Primarily, it would be a hub for scientific research. Additionally, such an outpost could test new technologies for surviving in extreme environments, which would be crucial for future space exploration, especially in harsh conditions like those on Jupiter's moons. Furthermore, by studying Venus's extreme greenhouse effect up close, scientists could gain a better understanding of climate change on Earth. Lastly, an outpost on Venus could act as a proving ground for technologies that might be used in terraforming efforts, exploring ways to make the planet more hospitable in the distant future. Constructing an outpost on Venus's surface would require materials that can withstand the planet's extreme high temperatures and crushing atmospheric pressure. The structure would need to be heavily insulated and cooled using advanced thermal management systems to protect against the intense heat. Additionally, it would have to be airtight and resistant to corrosion from the acidic atmosphere, potentially utilizing cutting-edge alloys or ceramics developed specifically for these conditions. In an epic chapter of human exploration, humanity turns its gaze to Venus, a world with a harsh environment unlike any on Earth. Venus's surface, with its extreme temperatures, toxic atmosphere, and intense pressure, presents a formidable challenge. Undeterred, humans ingeniously opt to inhabit Venus's upper atmosphere, creating Aerostat Habitats. These floating colonies, both stationary and mobile, provide sustainable living spaces and serve as scientific hubs. Here, amidst the clouds, humans live and work, researching ways to terraform the hostile planet, exploring concepts like converting carbon dioxide to oxygen and reducing solar radiation, demonstrating an unprecedented leap in interplanetary living and environmental manipulation. The venture into Venus's atmosphere paves the way for further innovations. Sophisticated mechanical hoists enable safe travel from the serene habitats to the treacherous surface, allowing in-depth planetary exploration. Surface outposts, designed to withstand Venus's extreme conditions, become beacons of scientific discovery, advancing our understanding of survival technologies in extreme environments. This bold exploration of Venus epitomizes humanity's relentless pursuit of knowledge and adaptability, marking a significant milestone in humanity's history as a species.